Hi, grade sixes. Look, I'm going to ask you in a second, okay? And when I say now, do it. But I'm going to ask you in a second to put your video on pause. Now, when I put it on pause, when you put it on pause, what I want you to do is go out into the house or wherever you live, find your mom, find your dad, find someone who's in charge, your guardian, whatever the case may be. Go find them. While it's on pause, bring them to me, and then when you bring them into the room and they're looking at the screen and they can hear what I'm saying, unpause it. Okay? Or better yet, if you're watching on your iPad or something like that right now, put it on pause, give it to them, and unpause it. Okay? So you can, when I count to 3 and say go, pause this and hand it over to a member of your family. Are you ready? 1, 2, 3, pause. Okay, you back? Okay. This is just a personal invitation to you because I don't know if your son or daughter has mentioned it. Tomorrow night here at Sir John A. Macdonald, we're having our annual open house. It goes from 6 till 7. We're going to spend a half an hour in the gym with the entire population of our school together, and then we're going to move up into the classrooms for a half hour. I'd really love to see you there. First of all, to meet you, but more importantly, also to introduce our classroom to you, and also to introduce some resources that we've put into place this year. All right, so that's tomorrow night, 6 till 7. There'll be pizza and barbecue stuff available to buy. Various members of the community will be there. It'll be a lot of fun. Make sure you stop on by. We'll have a chance to talk too. All right, so that's tomorrow, 6 till 7 here at Sir John A. Macdonald. All right, you can put it back on pause and hand it back to your child. Okay, here we go. Okay, good. We're back. Now, tonight I want you to think about a concept that we talked about really early in your school career, but it's going to continue and it's going to get a little more complicated. And that's the difference between prime numbers, composite numbers, and something called prime factors. Okay. Now, by now you know what a prime number is. At least I hope you do. We're going to review that. We're going to look at what composite numbers are, and we're going to talk about what factors are and how you come about prime factors. It'll become important to you as we go along, so you might want to really take a close look at this. All right. Here we go. Okay. Let's start off with talking about the difference between prime and composite. When we talk about a prime number, we talk about a number that is only divisible by 1 and itself. Okay? So we'll use the number 7. Okay? In order to get the number 7, when you're working with division or multiplication, the only two numbers that will actually work with it without breaking it into non-whole numbers, okay? Without going into decimals or remainders and that kind of thing, staying with whole numbers, you can either go 1 times 7, or 7 times 1, but you really can't do anything else with that, right? That's because 7 is a prime number. And what they mean by prime numbers is just that. The definition of a prime number is a number that can only be divided by itself and the number 1. For the very same reason, 6 is not a prime number, okay? Now, you can do 1 times 6 and 6 times 1, okay? But there are other ways you can multiply or divide to get the same number. For instance, 2 times 3, right? So you can do 2 times 3, 1 times 6, etc., 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 and still get to that number. That makes it a composite number, okay? 7's a prime, 6 is a composite. 1's a prime, 2's a prime, 3's a prime. 5 is a prime, 7's a prime. You get the idea. Is 9 a prime? No. So not all odd numbers are prime either, because you can do 3 times 3, you can do 1 times 9. There's other options, right? So if we look at any number, if you can do those two things, you can determine whether or not you've got a prime or a composite number. One of the things that we have to know about in grade 6 is whether or not we can identify what's known as a composite or a prime factor. Okay, it goes along the same idea, but it's something that we're going to be working on over the next couple of days. So I want you to see if you can look through it. So here's what I'm talking about. Let's take a number like 23. Okay, 23, if you think about it, really only has 2 factors, right? What are they? They're 1 and 23. Nothing else works that way, right? So a prime number is a number that's greater than 1 and divisible by 1 and itself. Okay? So if you were to break this up, this is the only way you could do it, the only way you can play with it. But let's say instead of 23, we're looking at the number 24, right next to it. Okay? What are some of the ways you can multiply two numbers together and get 24? Okay, each one of the numbers you're looking at is a factor. Any number times another number to get a product, those things are factors. All right. So let's look at the most obvious one, which is 1 times 24. Okay, 1 and 24 are both factors. All right. Okay, then let's take a look at some other options. You can go 1 times 24. You can also go 2 times 12. Okay. So 1's not a prime number, but 2 is, but 12 isn't. Okay. How else can we get to 24? Well, you can go 3 times 8. Well, 3 times 8. You can get to 24 as well. All right. Is there another way? How about 6 times 4? Okay, well, we can go that way too. Let's take that back and put it back here. So all of a sudden now we have a whole bunch. We'll put down 6 times 4. Okay, so now if we look at a prime number, again, 1 times 23, that's the only way you can multiply or divide to get to 23. That makes it a prime number. You can do 1 times 24 as well, but there's many other ways you can formulate that number. 2 times 12, 3 times 8, 6 times 4. This makes it a composite number. So if I were to ask you to write down all the factors of 24, there's 8 of them. There's 1, there's 2, there's 3, there's 4, there's 6, there's 8, there's 12, and 24. Now look at these numbers here. Those numbers right up there. Which ones are the prime factors? Okay. In other words, which one of the factors that are up there, in fact there are 2, which are the 2 factors up there that are prime? Well, 2 and 3. And I'll tell you why that's important. Look for just a second. Can you make these various mathematical sentences here, these equations, can you change those to reflect these 2 numbers? Well, of course you can. You can do 2 times 3 times 4, or 2 times 2 times 2 times 2. In other words, no matter how you do it, you can make it so that just 2 and 3 will always end up 24. Can't do that with 4, 6, 8, 12, and 24. Plus they're prime. They're numbers that are just for them. Okay, there are numbers that are just prime themselves, right? So what you're going to be doing tonight is you're going to be finding, first of all, the factors of each number, and then trying to identify what the prime factors are. Make sense so far? Okay. Tomorrow what we're going to do is we're going to talk about this and see how it ties into the rest of the stuff we're learning and the kind of things that you can use prime factors for. But for now, work on the stuff, try to identify them, and we'll see how you did tomorrow. Good luck.